So I think that we already kind of looked at these next couple of slides. But we did, I hope, see in the lab that the center of curvature that the curved surface of the mirror makes should be like twice as large as the focal length of the mirror. So hopefully after me checking stuff once or twice, you drew circles that matched the curvature of, in this case, it would be the concave side of the mirror. And if the center of that circle, like the pointy part of the protractor was here, wow, that's not very much in the center, maybe there, then the focal point, the point where all the parallel light rays converged, should have been like halfway to there. Right, so that's something that we're going to care greatly about over the next class or two. Hopefully we did see that the concave side of the mirror did converge those light rays, as we just said a couple minutes ago, and that the convex side of the mirror, so like this one, took those light rays that were originally parallel and caused them to diverge. And the reason that these mirrors are doing that is just because the law of reflection is always valid. So here, if we drew a normal to the mirror surface, it would be like here, and this angle of incidence has to equal that angle of reflection. But over here on this part of the mirror, right, the normal points differently, right? Because it's not a plain mirror, it's not a flat mirror. And that angle of incidence has to be equal to that angle of reflection. And then if this one really was oriented normal to the mirror, then the angle of reflection should be right back on top of the angle of incidence. So there's nothing other than the law of reflection that like governs all of this stuff with curved mirrors. All right, so let me pass out the lab that we're going to do today, and then I want to kind of immediately start off with a few troubleshooting points. So we're going to be using our optics kits again, but we're using like entirely different stuff this time than in the two parts of the first reflection lab that we did. All right, so first we're just going to focus on part one. All right, so part one kind of starts at the bottom of the front. And the only two things we need for part one are the concave mirror, a different concave mirror than last time, and the half screen. All right, so this is a half screen because it's like white on one half and it's actually empty on the other half. And then this actually has a concave mirror on one side and then a convex mirror on the other side. The side that's concave is the side that has the little label on it that says concave convex mirror, right? So that's the side that you want to use. And for this part of the lab, you're supposed to find some distant image that you're going to try and focus. You're going to try and reflect light off of the concave side of the mirror from that distant image and then focus that on your half screen. So let's see, what am I saying here? Right, so for your distant image, what I'd probably do, I think we'll keep the blinds closed, but go to this side of the room and then look for the doorway or look for one of the windows going into the hall, and then you need to point the concave mirror at that thing that you're trying to get a focused image of, and then the half screen needs to be like on the same side of the mirror as that image, right? Because light's not going to go through the mirror, it's going to reflect off of it. So you're going to kind of go like this, like I actually can't see anything because the overhead lights are on. If I turn them off, then I should be able to more easily sight stuff. So I'm going to go in, out, and oh, right about there, I see a really nice image of the crisp image of the windows. I'll try, I don't know if this will work for the camera, I'll try, I might be able to get a focused image of the screen. Had it. It might be a little bit, it's not really distant enough. Yeah, it's not distant enough. I can almost make out words at about that distance. So anyway, that's how you're starting part one. And then we're asked to find, where are we at? On the top of the second page, I think I covered up my handout. Oh, actually at the very bottom of the first page it says, as DO approaches infinity, what does 1 over DO approach? So there's an equation that you're given on this front side of the lab that we're going to be really focusing on and using for the next couple of classes. So the variables in here are, we have something called f, that's the focal length of the mirror. We have something called DO, that's the object distance, that's how far the object that you're looking at is located from the mirror. So in the example of focusing light from the windows, it would be the distance between the windows and the mirror. So the object distance is how far the object is from the mirror, just like it was for plane mirrors. And then the image distance is how far the image is from the mirror. So if we have a focused image on this little half screen, the image distance would be the distance between the screen and the mirror. All right? So if DO is really far away and approaches infinity, 1 over DO, 1 over infinity, pretty much becomes 0. Right? 1 over a super huge number is a super small number. So 1 over F, so 1 over DO approaches 0, and then this equation becomes just 1 over F equals 1 over DI. Right? So that should allow you to pretty easily finish part 1. And that's actually some pretty straightforward calculus that we just did. All right, part 2, we're using a few additional things. So there's really good diagrams on the handout for both of these parts. The diagram for part 2 is right underneath where it says part 2. And we're using a new thing. We're using the optics bench, which are these black benches that have like meter sticks built into them. And then we're still using the half screen, and we're still using the concave mirror. And these things fit super nicely into the optics bench. They just like snap right in, right? Voila. And then the other thing we need is the light source, but today we're using a very different mode of the light source. Let me plug it in so I can show you. What do you call it? B-Day section? You should probably go ahead and do part 1, and then when you finish part 1, come back and watch the rest of the video. Alright, so last time we were using like the ray mode and we were turning this thing. We're not doing that today. We want to use this thing today. Right? Because this thing has arrows, so that helps us out figuring out if things are inverted or not. And then this also fits really nicely onto the optics bench. Alright? On this one, these two little plastic things on the outside kind of straddle the whole bench. Alright, and then this tells you the exact distances that you should use for the object distance. So it tells you the exact distances you should use to have between the mirror and the light box. Alright, so let me make sure there was nothing else that I wanted to do in terms of troubleshooting. So we don't need meter sticks. You actually will still need a ruler for one other part. We already showed that those things fit really nicely. They do, I think I mentioned this already, but make sure for the object distance you're measuring the distance between the object, which is this lit up arrows, and the mirror, right? A common mistake is to measure the distance between the light kit and the half screen. No, that's nothing, right? The object distance is this distance, and then the image distance is this distance. What else? I already said that. And then the only other thing I can think of is at the end, they want you to measure the size of the object in the image for just one trial. The procedure has this somewhat complicated way to do that by like getting a scrap of paper and kind of fitting it on top of there and then fitting it onto the half screen. I don't think you need to do that. I think you can just hold your ruler up to those things and do good enough. All right, so those are all my warnings. If at any point you want to show me your data, that's fine. Do that. You are going to hand in 1 per person this time, right? Not 1 per group. You are going to be doing some graphing and some, more some calculations, which we haven't really done for the other optics kits labs. And make sure that you do include the kit letter in the heading. All right. So I think that's all I need to say. I do need to pull just maybe 1 person from each group to go get some laptop parts for me. But other than that, you essentially have the whole period to work on this and to hopefully get your data graphed up. Right? That's why we're going to go get parts. So let me know if I can be of any help. Once you have some data, you might want to show it to me so I can kind of confirm that it's okay. All right, go ahead, get your stuff.